Hey guys!
Hi friends!
We have a special guest today. Mrs. Herseth could
me.
hardly believe, oh yeah, that's Mrs. Herseth. She could hardly believe me when I said, hey, we're doing lesson 12, but Mrs. Herseth is basically the same as 11.
What? That's cheating, Mrs. C.
And I was like, Mrs. Herseth, I'm serious.
Actually cheating.
So then
What
we
is
said,
that? I don't even know.
maybe we could just make it a super fun video.
Okay.
And then Mrs. Herseth said, great, I love fun.
I love fun all the time and sparkles and sunshine and all the fun things.
So here's an extra fun video just for you guys. Okay, rascals, here's the deal. We are going to do this problem. 7 1/5 minus 4 1/3. There are, you guys know this very well, multiple ways to find a common denominator. One way, and I feel like this is, you're probably thinking about this in your sleep. One way is just to multiply the denominators together. 5 and 3. 5 times 3 is, thank you, Evan, 15. Another way to find a common denominator is just to do some classic skip counting here on the side. You have to skip count by both numbers. So we have 5, 10, 15, 20. And then we have 3, 6, 9, 12, 15. Stop me when, oh, thank you. Charlie, Brady, just noticed that 15 occurs in both of our lines, 5 and 3, meaning 15 is a common denominator. As it turns out, that was the same common denominator we found out here. You're brilliant. Can't stop you now. So now we're going to go ahead and rename 1/5 as an equivalent fraction with a denominator of 15, and we're going to rename 1/3 as an equivalent fraction with a denominator of 15. But wait, don't forget to bring down those whole numbers, Mrs. Herseth.
What?
Don't forget to bring down those whole numbers, Mrs. Herseth.
Oh, okay, got it.
Yeah, 7 and 4. You see how we did that?
Got it.
Cool.
Yep.
So now we need to ask ourselves, what did we multiply 5 by to get 15? Well, as it turns out, all of the work is up here. Tracy, what did we multiply 5 by to get 13? Is that Tracy's hamster answering? What is Tracy's hamster's name again? Nibbles?
Tickle.
Tickle.
Pickle.
Thanks, Pickle. Tracy, I'm sorry for getting your hamster's name wrong, but Tracy's hamster just told us that 5 times 3 is 15. Tracy's hamster is also telling us that if you're going to multiply 5 by 3, you have to multiply 1 by 3, because you guys know that numerators and denominators are insanely jealous, and if you don't multiply them by the same number and treat them the same way, things are gonna get weird. So just go ahead and multiply that 1 by 3. McGruff, what is Eva E's dog? McDuff is telling us that 1 times 3 is 3. Thank you, buddy. And now we just need to go over here and continue this good work. Thinking about 3 times some number is 15. Well, we already did the work over here, so it kind of spoiler alerts it. Ava Lemon, thank you. 3 times 5 is 15. And if we're going to multiply 3 by 5 down here, we have to multiply 1 by 5. Just don't even start anything between those numerators and denominators. We don't have time for that. Also, Natalie, I'd like to point out that this is subtraction. Okay, Natalie, just make sure you're subtracting. And now let's just subtract our whole numbers first. 7 minus 4. Mrs. Herseth, do you want to handle that one?
3?
Good job, Mrs. Herseth.
Winning.
And then we just Oh, this is a good one. Did I mess up? No, I didn't. Okay, 3 minus 5. We cannot take 5 from 3. Oh, good. This is a little bit more challenging than I thought it was going to be, but we can handle it. So we're going to that out. We cannot take 5 out of 3. We're going to have to unbundle here so that we can subtract here. So 7, we're going to rename 7 as 6 plus 15 fifteenths. 6 plus 15 fifteenths is equal to 7, because you guys know that 15 over 15 is just a fancy way for saying whole number 1. So 1 plus 6 is 7. We're renaming 7 as 6 plus 15 over 15. But we can't leave those 3/15ths behind. So let's rename this whole number as 6 and 3 fifteenths is equal to 18 fifteenths. We just renamed 7 and 3 fifteenths as 6 and 18 fifteenths. Now let's rewrite our expression. Draw a rectangle. Pretend this is a new line. 6 and 18 fifteenths minus the 4 and 5 fifteenths. Let's see if we can do that now. This is actually a good one. I'm happy that we are being called to duty on this one. Okay, so Mrs. Herseth, 6 minus 4?
6 minus 4 is dos, or 2.
Oh, oui. Beautiful. And now we have 18 minus 5. We can take 5 from 18. Up here, we could not take 5 from 3, so we had to unbundle, regroup, and rename 7 and 3 fifteenths as 6 and 18 fifteenths. Now we can absolutely move forward on this question. So 18 minus 5, last time I checked, Kendi, do you have that one for me? Thanks, buddy, is 13 fifteenths. So our final answer here is 2 and 13 fifteenths. Good day. Hey guys, we are back. Let's just do one more problem here. We're looking at 17 and 2/3 minus 5 and 5/6. You guys know there's more than one way to find a common denominator. I have a feeling at this point a lot of you are already just kind of analyzing the denominators and thinking, do 3 and 6 have anything in common? Let's just do some quick skip counting over here on the right. So if I'm skip counting by 3s, I have 3, 6. If I'm skip counting by 6, I have 6. Oh, cool, 6. 6 is the common denominator between 3 and 6. This is awesome because the denominator here is already 6, so we don't have to do any work. So I'm just going to bring 5 and 5/6 down. And we're going to bring our 17 down. And all we need to do is convert 2/3 to an equivalent fraction where 6 is the denominator. So let's think about 3. 3 times what number is 6? 3 times what number is 6? 3 times 2 is 6. Thank you very much, Fiona. And if we're going to multiply 3 by 2, you guys bet your bottom dollar we need to multiply 2 by 2 because, as you know, numerators and denominators can be insanely jealous and can have giant fits if not treated equally. So we multiply 2 by 2 and we get 4. Now let's look at this. I think we got a little stung on the previous problem. Perhaps lesson 12 is giving us a little bit more of a challenge than I thought it would be. So you guys are probably already noticing that we can't take 5/6 from 4/6. So what we need to do is rename 17 and 4/6 so that we can have a few more 6ths to work with. So we're going to rename 17 as 16 plus how many 6ths? Thank you, Kylie. 6 sixths. Because you guys know 6 sixths are just a fancy way of saying good old-fashioned number 1. So we just renamed 17 as 16 plus 1, or 16 plus 6 sixths. But don't leave those 4 sixths behind. Let's bring down the 4 sixths, and let's see what new number we're dealing with. So we're just going to bring down our whole number, and then we're going to add our sixths. 6 sixths plus 4 sixths. Thank you, tell me that. Thank you, Charlotte. 10 sixths. So we have just renamed 17 and 4 sixths as 16 and 10 sixths. We had to unbundle one whole out of 17, so we have more sixths to deal with because what we're trying to do is take away 5 sixths, and you guys know that we can't take 5 from 4. So we just kind of manipulated the numbers so that we can now carry on with the good work. So let's see how this looks. 16 from 5, that's going to work. 10 from 5. Okay, cool. We're all good. 16 minus 5. Oh, wait. Mrs. Herseth, do you have a secret word for us?
I do. Your secret word for today, January 17th, is, drumroll please, Patriots. Yes, Patriots, but think the revolution.
Oh, thanks, Mrs. Harrison.
Oh, you're welcome.
16 minus 5. Who's got it for me? Christopher. Thanks. 11. 10 minus 5. Or 10, 6 minus 5, 6. Thank you, Maggie. 5, 6. Final answer here. 11 and 5, 6. Please bring your secret word into class tomorrow and be prepared for some more amazing work in Mathland. That's all for now, kids. Goodbye.